Assalamualaikum everyone, welcome back to my channel. So did you guys know that food dyes have their own chemistry? Would you want to drink a black water or a clear Pepsi? Well, in fact, these products actually existed not long ago, but it did not really last long because people prefer to eat something that the color matches the flavor. Yeah. Well, so here come the natural food coloring. There are four most common types of food dyes. The first one being carotenoids. The second one, chlorophyll. The third one, anthocyanins. And the last one, turmeric. Number one, carotenoids. Carotenoids has a deep red, yellow, or orange color. The most common carotenoids is probably beta-carotene. Beta-carotene is responsible for the bright red in sweet potato and pumpkin, and carrots, and many more. Since beta-carotene is soluble in fat, it is a great choice for coloring dairy products. So here is beta-carotene molecule. Beta-carotene is composed of two small 6-carbon rings connected by a chain of carbon atoms. Second one, chlorophyll. It's often found in green plants. Number 3, anthocyanins. Blueberries and grapes get their color from this organic compound. Unlike beta-carotene, anthocyanins, which form a class of similar compounds rather than a single chemical compound, are soluble in water. More than 500 anthocyanins have been isolated from plants. They are all based on a single basic core structure, the flavillum ion. This ion contains 3 6-carbon rings as well as many hydroxyl groups that make the molecule polar. It has partially negative and partially positive charges and water soluble. Chemical structure of an anthocyanin, R1 and R2 are functional groups, and R3 is a sugar molecule. So another natural food coloring that you might know is turmeric. Turmeric has a color of deep yellow. Turmeric is also a good acid or base indicator. If you add basic substance to mustard, it will turn red. So did you guys know that your food might contain bugs juices? So the next time you enjoy a strawberry flavored yogurt or cranberry juice, you might be eating a bug. But don't worry, these insects do not contaminate your food by accident. An extract from a certain bug called cochineal was deliberately added by the food manufacturer. If you crush up 70,000 of these bugs, you can get a pound of deep red dye. It is called the carminic acid. This is the chemical structure of carminic acid. So if there are natural food dyes, why do we have to go artificial? So it has been figured that synthetic food dyes can be mass produced at the same cost that you go to find and process the materials of natural food coloring. Another reason is shelf life. Artificial dyes can last longer than natural food dyes. Also, not all natural food dyes are suitable for foods. There's also no limit of making variety of colors in lab. There is this 7 synthetic food dyes that is widely used in the world. These food colorings are summarized in this table. So how to color food? What makes a good food coloring? Firstly, if added to water, it should dissolve. If it's not soluble, it would not mix evenly. When a typical solute, a salt or sugar, is added to water, it dissolves. It is broken down into individual ions or molecules. For instance, individual molecules of sugar are held together by relatively weak intermolecular forces. So when sugar dissolves in water, the attractive forces between molecules are overcome, and these molecules are released into water. Food coloring molecules are usually ionic solids, which is they have positive and negative ions, which are held together by ionic bonds. When one of these dissolves in water, the ions that form the solid are released into solution. They become associated with polar water molecules, which have partially negative and positive charges. Another important property in food coloring is when it dissolves in water, the color remains. The reason this happens is because the food coloring molecules absorbs the wavelength of lights and let the other pass through, resulting in the color we see. Absorption of light is caused by bringing an electron into molecules, ion, or atoms into a higher energy level. Blue absorbed light is orange, complementary color to blue. For red, the absorbed light is green, complementary color to red. Thank you for watching.